Welcome back to another episode of the Dish TV. I'm Renita Malhotra Khora, Head of Marketing and Communications at SRI International. And I have with me today Dr. Karen Myers, who is the Lab Director of the Artificial Intelligence Center here at SRI. Karen, great to have you on the show today.
Happy to be here. Thanks for the opportunity, Renita.
When I think about artificial intelligence as a field of research and development in the tech world, correct me if I'm wrong, but our AIC is synonymous with the development of the concept in and of itself, right?
That's correct. So the field really got going in the early 60s, and SRI was certainly at the forefront of the field starting back then. So SRI, Stanford, MIT, Carnegie Mellon University, these were the really big players that were responsible for a lot of the foundational work that really kicked off the field. SRI participated in a number of notable projects and had a number of great accomplishments back then, but maybe the one that's the most endearing and the best known is Shaky the robot. SRI built the first intelligent robot, one that could actually accept goals or tasks from humans and figure out what it needed to do to accomplish those tasks, and combine that then with perceptual processing, so it could figure out where it was in the environment, what was in the environment, what it was capable of doing, and then actually plan its movements in that environment. And that's something that led to invention of a number of really important concepts and algorithms that are still quite widely used in the field today.
There are three waves that you talk about, three waves of AI. Can you explain what these are, what that means?
Sure. People now talk about the three different ways. The first wave being, some people call it good old-fashioned AI. So it was really the paradigm that dominated the field from the early 60s up until, the early 2000s, mid 2000s. And the concept there was that what we were trying to do was build up models of problem-solving knowledge in rules or logic, trying to represent things that way, and then have this system reason with those rules the way we like to think that people can reason about complex tasks using logical inference, deduction, those kinds of things. So that kind of led to the second wave, which is really about a data-driven AI, so machine learning, in other words. So that's really been the predominant paradigm for the last 15, 20 years or so. So within the second wave AI, then kind of the concept is that the data is everything. You start with the data, you apply your machine learning algorithms, and from that, you'll get out the models that give you the intelligent behavior you're looking for, whether it's, the ability to recognize things in images, or to interpret text, or so on and so forth. So that's the second wave. And we've had some phenomenal successes with the second wave. And it certainly has revolutionized a lot of our lives in terms of things like real-time speech recognition, self-driving cars, those kinds of things. So although there have been these great successes, the second wave isn't sort of the panacea that solved everything. And that's why people are really looking to this third wave, which in some ways you can kind of think of it as a combination of the two. Sort of a recognition that there are benefits to both the first wave approach of pre-encoding knowledge, because you can capture human insights and expertise readily in some applications. So why not take advantage of that? And then combine that then with the insights that can get from machine learning algorithms applied to large data sets. So pull those together into kind of a hybrid approach that hopefully will give us the best of both worlds.
Looking at those three waves, that's one way to understand the evolution of AI research and development. Mm-hmm. Sure. What's the right way to say this? How do I begin to think about how to further subdivide our AI capabilities so that rather than AI in general, it's these different areas and link them to these specific examples of what we're doing?
Yeah, so you could talk about sort of technical foundations for AI. And if you did that, there would be things like machine learning, obviously, but also things like knowledge representation, how you capture information and store it away so it can be used. And then complementing the representation would also be reasoning or inference techniques. So given you have either learned or manually compiled knowledge, then what do you do with it? How do you apply that knowledge to help you with problem solving? So that's one way to take a cut at the field. I guess another is to look at it from the perspective of the different kinds of applications to which you could apply AI. So without getting into, specific verticals, some of the applications that AI people like to talk about are things like, computer vision or natural language understanding, speech recognition, planning, those kinds of application areas. So those are maybe two different ways to carve up the pie, so to speak.
Karen, when I think about the work that the AIC is doing right now, what kind of innovations could this lead to in the future?
Yeah, well, so, we talked a little bit about third wave, and I think that's a really exciting area. It really is state of the art in terms of, how do we bring together the best of human knowledge with the best of what machine learning can get for us from analyzing large amounts of data. And there are lots of really interesting research challenges that come out of this. I mean, one is just getting the human insights to influence machine learning, and Dazzle is an example of a great technology that we have that it really is sort of cutting edge in that space. There are other kinds of issues, though, around these types of systems. So one is understandability. So if I've got a great deep learning system, it seems to be producing good results, but I don't understand why. Am I really going to trust that system? What you'd really like to do is be able to, query the system and say, well, you're recommending, this course of action. Why is that? Did you take these factors into account? What if we tried this other thing? So the field as a whole is not really yet at that point where we can have this really human understandable, or it's often called interpretable in the community, interpretable models of how the deep learning algorithms are working. So we're doing some interesting work in this space in various ways. In addition to Dazzle, we've got some work that's going on explainable AI and trying to provide insights into how the deep learning systems are coming up with the models that they're coming up with. So, but within reinforcement learning for autonomy, then it's a really hard problem for the system to be able to somehow characterize what it's doing and why. And so one dimension that we're taking there is one of our research staff has developed this concept of interestingness elements. And what the concept is here is that the system is doing introspection over the learned model that it has, and it's identifying things that to it thinks that they're pretty interesting. And so you might ask, well, what kind of things might those be? So as an example of something, it might be that, here's a set of conditions. Whenever I get into a state that satisfies those conditions, I always fail. or similarly, it could be whenever these conditions are satisfied, I seem to do pretty well on the task. So what we're trying to do here is build a system that can do this kind of reflection to identify these interesting states and actions that it can take in those states. And use that as a way then that it can sort of have conversations then with a human about some of its problem solving. It's trying to characterize what it's doing in terms of these interesting elements it's able to find from its models. So
when we think about our current capabilities for the AIC, can you explain to me, are they all that hybrid sort of third wave approach? Do they all fall into that category right now?
So interestingly, no, some do. That's really kind of the research frontier right now. And we're doing a lot of great work on that frontier. But maybe before we focus on that, I'll just back up and say that, yes, we're doing a ton of work on data-driven machine learning. It's a very hot field right now. We're doing some great things there in terms of computer vision, natural language processing, text analytics, that sort of thing. Also, reinforcement learning for developing models for autonomy for intelligent agents. But we're also still doing a fair amount of what would be considered first wave work. And there's a good reason for that. There are demands for building technologies of that sort. So a really good example of that is some of the work that we're doing in the bioinformatics sphere. We've got a framework called BioPsych and accompanying tools called Pathway Tools. BioPsych is a portal to a number of databases about organisms. It captures genomic and pathway information for a range of different organisms. And we've got 11,000 licensees of our software who want access to that information. One of the things they really value about it is that it's been highly curated. It's content that's come from over 120,000 different publications. So they really trust that information, and that trust is important to them because they're looking at applications where it's really, really critical that some of the results that they're getting are based solely on information that they can highly trust.
Very enlightening conversation, Karen. Like I said at the outset, once I start talking with you, I never seem to want to stop. Thank you so much for joining us on the show today.
Well, thank you very much, Renita. It's always a pleasure talking with you and talking about all the great things that are happening within the AI Center. So we appreciate the opportunity.